So dear students, in the last class I have discussed about the electric field due to uniformly charged rod but at an axial point. But now let me discuss about at perpendicular distance. So here I have taken a perpendicular distance A, okay, and from the middle point of the rod. So this portion I have taken as L and this portion also I have taken as L, okay, and the perpendicular distance is A here, and this is the field point. This is the field point. Now to determine this, we have drawn a certain geometry, that is we have taken a small length, okay, dx over here, and this is the dx, and the charge on this element dx is dq, okay, and the similar dq we can take here also because we have taken this as origin. So this is our origin, okay, this is a midpoint. So we have taken one dq in this side and the similar dq in this side also. So here also there will be dq, another dq. Now for this dq, the electric field at this point is d, which is along this direction, okay, and for this dq again the electric field is along this direction, and this is d, okay. Now if you resolve this to d, so if we draw this line, so at this angle I have taken theta, so this will also be theta and this will also be theta. So if you resolve this d, so one component is along this direction and that is d sin theta and another is d cos theta, d cos theta. For this d also, one is d sin theta, okay, and along this direction that is d cos theta. So you can see d sin theta and d sin theta will be cancelled out, and the net electric field at this point will be 2d cos theta, okay, 2d cos theta. So if you talk about at this point, so it will be just electric field due to this dq and this dq, so that will be 2d cos theta, okay. And if you talk about the net electric field for the whole rod, okay, then we have to integrate with this expression. So if you talk about E, and that will be integration 2d cos theta, okay. And as you have taken 2d cos theta, dq this side and this side also, so we don't need to vary dq from minus L to plus L. If we vary dq only from 0 to L, then the whole rod will be covered, because this two term will be taken here. Why I have taken this 2? Because I have taken two similar dq from both sides. So if you use just d cos theta, you can use. If you use only d cos theta, then the limit will be from minus L to plus L. But if you take 2d cos theta, then you just have to vary from 0 to L, because this side and this side is similar from geometrical point of view. So you can, if you take inside the integration 2d cos theta, then you can take the limit only from 0 to L, okay, that will give the total electric field at this point P. So the electric field at this point P is integration 2d cos theta. Now let me convert this whole, all the terms in terms of x, because we want to integrate along this. So we have to express this expression in terms of x, and you can find the electric field d. So what is d? In terms of x you can write d. So what is d? So you can see d will be just here, that will be 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught into dq divided by, what is the distance from dq to here, from dq to field point, as this is a and this is x, so this will be obviously root a square plus x square. So this will also be root a square plus x square. These two are same. This d and this d are same, because the charge are same dq and the distance will also be same, root a square plus x square. That's why I have taken 2d as same. So it will be just divided by square plus x square, okay. So root a square plus x square whole square, that is a square plus x square. So this is d. And what is dq? dq is lambda dx, because we have lambda is equal to, we have lambda is equal to what? lambda is equal to dq by dx. Okay, so what is dq? So dq will be lambda dx. Okay, so dq will be lambda dx. So we can substitute here, instead of dq we can substitute lambda dx. So it will be 1 by 4 pi epsilon naught into lambda dx divided by a square plus x square, divided by a square plus x square. Okay, so let me substitute here du and cos theta. And cos theta, what will be cos theta? Cos theta will be base divided by hypotenuse. And for this triangle you can see the base is a. Okay, because this is the perpendicular, this is x is the perpendicular. So you can substitute here all the terms. So e will be, we have integration 2 into, and instead of d we can write 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught into lambda dx divided by a square plus x square. Okay, and for cos theta we can find from this triangle that cos theta is equal to base divided by hypotenuse, and here base is a, okay, with respect to this angle theta, and hypotenuse is root square plus x square. So what will be the expression? So let me take all the constant outside the integration. So here lambda is constant, a is constant, 2 is constant. So we can write it like this: 2 lambda a upon 4 pi epsilon naught. This is the constant term, and within the integration we have to write dx divided by a square plus x square to the power 3 by 2. Okay, now we have to integrate this expression dx by a square plus x square to the power 3 by 2. Let me put here for x is equal to a tan phi. So we can put here x is equal to a tan phi, because we have used already theta, so I don't want to use the theta again. So we can take x is equal to a tan phi. So if x is equal to a tan phi, then dx will be what? Dx will be a into sec square phi d phi. Okay, let me put here, and here limit will be, for x limit will be 0 to L, 0 to L. But for phi, so when x will be 0, okay, then phi will also be 0. But when x will be L, then tan phi will be L by a. So tan phi will be L by a. Okay, and phi will be tan inverse L by a. So I will substitute in terms of phi. So let me take the limit from 0 to phi. Okay, so we can take the limit. So 2 lambda a divided by 4 pi epsilon naught, and the limit will be from 0 to phi in terms of phi. Okay, and now what is dx? So dx is a sec square phi d phi divided by, if you take here x is a square tan square phi, so it will be a square into 1 plus tan square phi. Okay, a square plus a square tan square phi. So if you take common a square into 1 plus tan square phi, that will be sec square phi, and sec square phi to the power 3 by 2, that means sec cube phi. So it will be just sec cube phi, and for a square to the power 3 by 2, that will be a cube. Okay, now so it will be just 2 lambda a divided by 4 pi epsilon naught into integration 0 to phi, and 1 a will be also outside. Okay, because here is a and here is a cube, so sorry, it will be a square, and sec square phi sec cube phi, that will be 1 by sec phi, that will be cos phi. So integration 0 to phi cos phi, and integration of cos phi is sin phi, and limit will be phi to 0, so that will be sin phi. So it will be just 2 lambda a divided by, so a and a square will be cancelled out, so 1 a will be denominator. Okay, so it will be 4 pi epsilon naught a into integration cos phi is sin phi, so it will be sin phi. Now you can put the value of sin phi, because we know tan phi. So if we know tan phi, then from here we can find out sin phi also. So sin phi will be what? Perpendicular divided by hypotenuse, and this is perpendicular and this is base, so hypotenuse will be root L square plus A square. So we can write here, so the expression, final expression will be 2 lambda divided by 4 pi epsilon 0 A, okay, into L divided by root L square plus A square, L divided by root L square plus A square. So this is the final expression. So the final expression of electric field, if you talk about E, okay, so the electric field, expression of electric field is nothing but 2 lambda L, it will be 2 lambda L, or you can write it like this, 1 by 4 pi epsilon naught A, 1 by 4 pi epsilon naught into 2 lambda L into 2 lambda L divided by A into root L square plus A square, or A square plus L square, you can write it like this, okay. Now this is the final expression for electric field at a perpendicular distance A, where lambda is the charge per unit length. Sometimes it can be written as Q by L, there is no problem. But if we convert this result for infinite rod, if you take infinite rod, okay, then your L tends to infinity. So if you substitute here L tends to infinity, then you will get the result for infinite rod, okay. And for L tends to substitute, this is the result, final result actually. Now if you want to substitute L tends to infinity, then you can modify this expression. So we can write this again as 1 by 4 pi epsilon naught into 2 lambda divided by A, okay, and square root of, here you can write as, okay, so if we divide with this L, then it will be just, you can find it will be just A square divided by L square plus 1, it will be like this. If you put this L here, then it will be divided by L square, okay, because inside the root it will be L square, so A square divided by L square plus 1. Now if you put the limit here for infinite rod, so you can write that for infinite rod, what we have L tends to infinity. So for infinite rod L tends to infinity, so it will be just, so if you put here infinity, then it will, this term will be 0, okay. So E will be what, if you put here infinity, then something divided by infinity will be 0, so this square root term will be just 1. So your final expression will be 1 upon 4 pi epsilon naught into 2 lambda by A. So this is your result for infinite length, and we will verify this result by using Gauss law also, okay. Thank you.